John is given a prescription for blood pressure tablets by his doctor. Each tablet contains 5 milligrams of the active medication. The mass of active medication A remaining in John's body T hours after taking a single tablet is given by A of T is 5e to the negative 0.0173 T, where A is in milligrams. Calculate the mass of medication remaining in John's body 10 hours after taking a single tablet. So A of 10 is just going to be 5e to the negative 0.0173 times 10. And we just need to calculate that. And that gives us 4.21 milligrams, correct to 2 decimal places. After how many hours will the mass of medication remaining in John's body have halved? Well, if it starts off as 5, we can do that by putting A equals 2.5, so that's half, and that's going to be 5e to the negative 0.0173 T, or if you like, e to the negative 0.0173 T is equal to a half, and we can just solve for that. So just on the class pad, just go for solve, and 0.5 equals e to the negative 0.0173x, and that gives us 40.07 hours. Determine at what rate the mass of medication remaining in John's body is decreasing 24 hours after taking a single tablet. So we're talking about a rate of change, and therefore we need to differentiate. So the initial A was 5e to the negative 0.0173 T. And that gives us A dashed is going to be 5e to the negative 0.0173 T multiplied by the differential of the inside function, negative 0.0173, and that gives us negative 0.0865 e to the negative 0.0173 T, and just we want it after 24 hours, so A dashed of 24 is going to be negative 0.0865 e to the negative 0.0173 multiplied by 24. Calculating, that gives us negative 0.0571, and that would be in milligrams per hour. If a tablet is taken every T hours, the mass of medication B remaining in John's body immediately after taking a tablet will be given by B of T is equal to 5 over 1 take away e to the negative 0.0173 T, where B is in milligrams. If you want to think about where this comes from, you don't need to. It's the sum to infinity of a geometric progression where after he takes the first tablet, immediately after, he has 5 milligrams. And then if he takes one T hours later, he would have 5, that's from the new tablet, plus 5e to the negative 0.0173t from the tablet he took t hours ago, and then that would continue. So the next one would be 5 from a new tablet, 5 from the tablet he took here, and that would have this much, and then the tablet he took at the beginning would have this much, and that would be a 2t there. And basically it's looking at this continued on sum to infinity. That's how they got it. How frequently should John take a tablet so the mass of medication remaining in his body immediately after taking each tablet is 8.85 milligrams? All we need to do is set B equal to 8.85, and that's over 1 minus e to the negative 0.0173t, and just solve that. And you can see that I have done that on my class pad over here, and I get t is equal to 48.11 hours. They accepted 48. Use the increments formula to approximate the change in B if the time between taking tablets increased by 30 minutes from the time determined in part D. So the first thing we need here is dB dt, and you certainly do that manually, but you can do it on your class pad as well. I've already done it. Let's just have a look. Here it is. So I've differentiated that and I get this. If you look at the mark scheme, it says negative 0.0865 on the top. That 0.0865 is just the 173 over 2000. So I've done it in standard, otherwise it does look a mess because it does the E as 2.718 and so on. So we can write down what we have here, 173 e to the, and I know that that's negative 0.0173 t, and divided by 2000 e to the negative 0.0173 t squared. And I nearly missed the negative 1 there. You might have felt more like writing that as 1 take away e to the negative 0.0173 t, like that, rather than the other way around as the calculator's done it. Doesn't really matter. And then because it's squared, it doesn't matter. And then dB dt evaluated when t equals 48, which is the answer to the last part of the question, turns out to be negative 0.118. And so the delta B is going to be the dB dt when t equals 48 times the delta t. 30 minutes is half an hour, so 0.5. So it's just going to be this multiplied by this, which is negative 0.059 milligrams.